Hello everybody, today we're gonna explore the diverse usage areas of hyperspectral imaging technology. I am Hilmi, I'm a PhD student in food engineering. First, look at the fundamentals of hyperspectral imaging, then environmental monitoring and agriculture, industrial and manufacturing applications, medical and biomedical uses, finally defense, security and remote sensing. So let's first start with the fundamentals of hyperspectral imaging. So in the previous video, we talked about the basics of hyperspectral imaging. So our advantage was the higher spectral resolution. It's quite important because it will help us to identify the materials. Let's go. Well, first, just to understand a little better, in the last video, we also compared multispectral imaging and then hyperspectral imaging. Hyperspectral images give us higher spectral resolutions, which mean we can understand the whole spectra. We can get all the information that we can obtain from that material at that range. It's quite important. It gives you a lot room to go. So first, the key components for hyperspectral images, what was they? First, the sensors, dispersive elements to act as a prism to diversify the lights that we want to look at, the area that we want to look at. And then we have detectors, we have data processing units. All those components are necessary for a successful hyperspectral imaging analysis. And then let's go to the area of environmental monitoring and agriculture. Well, the thing that you can do with HSI, you can make crop health assessment and yield prediction. So you can detect early stress and you can forecast your yields, which will help you even before harvesting. You would know how much yield that you're gonna get that farm. So economically, you will prepare the result. Another thing is there are diseases in the plants, sometimes even not visible to the eye in the early stages. By using hyperspectral systems, since you have a lot of spectral resolution, you would catch those early stages of the disease and then you can take precautions. So stress detection in plants, spectral reflectance changes exposed plant stress, enabling timely crop protection measures. And you can also monitor water bodies and soil composition. So it's quite important to analyze your water time to time, even continuously, since hyperspectral imaging is a non-damaging, non-destructive analysis method. You can analyze your water before giving to the public, let's say. So with this way, you can detect pollutants and you can assess water quality in early stages and you can protect aquatic ecosystems effectively. Another thing is soil property assessment. You can, let's say you have a farm, you can analyze the soil time by time so that you realize what parts of your soil is rich in which materials. Quite important to know which part of your farm. So by knowing that, you will be able to plant proper crop to that part of your farm. And then it's quite important in environmental conservation because since you will detect the changes and the pollution in the environment, you can take precautions. Another area of it is industrial and manufacturing applications. You can make defect detection. Let's say you want your product to be perfect in a lot of sense, but for just looking at with your eye, some defects are not observable. So you would use hyperspectral imaging systems to detect those defects. And material consistency, it's quite important in industrial production. Your materials should be consistent. So if you could, again, catch early stages of inconsistency, then you would exclude that inconsistent parts without spoiling your end products. I'm a food engineer, so this is kind of my area. We are using hyperspectral imaging for food analysis because it's non-destructive. So without using any chemicals or without applying any physical damage to your food samples, you can analyze it, which helps you while you are using it in the production, let's say. You can look at all your products and this helps you to control your outcomes, control your food. If there are any kind of consumer safety issue, quality control problem, you can detect them in the early stages, and by doing that, you save your company from a lot of trouble. And also, let's say you are taking raw materials, you need to cut a price for that specific raw material. Let's say if you are taking sugar beets, you need to know sugar content, sucrose content. If sucrose content is high, you need to pay the provider higher price. If it's low, lower price. But by using hyperspectral images, since you can look vast amount of samples, the chances that you are wrong or the chances that you are paying in inappropriate amounts to your provider is very less. By using hyperspectral images, non-destructively, you can sort those raw materials, let's say, because the difference in sucrose content, for example, cannot be seen by naked eye or some conventional cameras. With the help of all that spectral information, you can analyze food and you can look at it in a lot of aspects. And lately what we did, we analyzed chocolate blooming. With this way, we were able to catch early stages of the blooming, so that if some chocolate is gonna bloom after we package them and the consumer gets them, it's not a good thing for us. What we did, we early detected them and we removed them from the production line, and then we re-tempered them so that they can be very consumer friendly, they can be very presentable, let's say. Okay. Another thing is sorting and classification. You can sort your products, let's say, according to their quality level. Another usage area of hyperspectral images is medical and biomedical uses. So you can basically make non-invasive tissue analysis without physically damaging or rupturing the tissue. You can non-destructively analyze, let's say you are looking for some skin cells that are a little bit problematic. Then what you do, you take an hyperspectral image. Since you have a very good spectral resolution, you can detect problems in early stages. So it's quite important in health. It's quite important in medical area. You can also make oxygenation measurements. It provides precise measurements of tissue oxygen levels, which is crucial for accurate medical diagnosis and treatment planning. And you can use it for drug development and research. Since it's non-destructive, you can use that for all the drugs that you are sorting, that you are gonna package and give to the customer. So since it's non-destructive, you can analyze your whole samples and you wouldn't miss any kind of defect or chemical problem on your drug. In the areas of defense, security and remote sensing, you can put your hyperspectral cameras to the satellites, so you can again look for the objects and activities in complex environments, and by this technology you can identify objects, interest in challenging conditions. Detection of hazardous materials, it's quite important. Let's say there is a gas leakage or a big ship is dropping some kind of unwanted material to the sea. By the hyperspectral images, even that they are not visible to the eye, you can detect those hazardous materials, and in early stages you can take again precautions by using hyperspectral images. Another thing is disaster response and management. Any kind of, let's say, earthquake or explosion of a nuclear factory, you can basically use hyperspectral images to assess the dimensions of the damage. It's quite important. Finally, as you see, we have broad application fields. Hyperspectral imaging is utilized in diverse fields, including environmental science and defense. For enhanced data capture, we have very detailed spectral data. We have enhanced decision making. It's quite important. Okay, let's stop it now.